Okay, today we're going to talk about rectangles, so a specific type of parallelogram. And here are some properties of rectangles that you need to make sure you're aware of. So first, it is a parallelogram. So that means all of those properties of parallelograms that you know also hold true for rectangles, meaning opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side interior angles are congruent, diagonals bisect, and so on. They also have the following specific properties that you're going to want to memorize, and those are listed here. All the angles are right angles. Opposite sides are parallel and congruent. I just said that. Opposite angles are congruent. Again, you should already know that. Consecutive angles are supplementary. You should know that as well, because that's all of those are true in a parallelogram, and the diagonals bisect each other. So these four are those same properties that you know about parallelograms. This is an added one. That's not true in a parallelogram necessarily. In a rectangle, you will have four right angles. Now, something new that's specific to a rectangle is something about its diagonals. So up above, we know that the diagonals are bisecting each other, but what we also know is that in a parallelogram, if it's a rectangle, that the diagonals are congruent. So in this case, JL would be congruent, segment JL would be congruent to segment MK, but what that also means is that all four parts are going to be the same because they also bisect each other. So we're going to look at an example here. So in this example, it says if the length of TS is 120, find the length of PR. So PR is that whole diagonal. We know if ST is 120, then QT is also 120, and then these two would be 120 as well. So the length of PR would be 140. Okay, then we have if the measure of angle PRS, if measure of angle PRS is 64, so I'm going to put that right here. Hopefully you can see that. Find the measure of angle SQR. SQR. So we're looking for this angle up here. What would that angle right there be? So what we need to remember is, since this is a rectangle, then all four angles are right angles, which means if this angle here is 64, then if I subtract that from 90, that would make this angle, what, 26, right? Okay. And so if that angle is 26, so since that angle here is 26, what we have here is a triangle. And if you notice, these two segments are the same. So we're looking at an isosceles triangle. And so remember that in an isosceles triangle, those base angles are going to be congruent to each other. So that angle is going to be 26. So the measure of angle SQR is equal to 26. Okay, the last example like this says quadrilateral JKLM is a rectangle. If the measure of angle KJL, so KJL would be here, if that is 2x plus 4, and the measure of angle JLK, that's here, is 7x plus 5, we want to find x. So if you look at this, we have a triangle here, and you should notice, because we know it's a rectangle, we know this angle up here is 90, so we're looking at a right triangle, which means all three of those angles add to 180. And remember, if one angle is already 90, then we know that these two have to add to 90. They have to be complementary. So 2x plus 4 plus 7x plus 5 would be equal to 90. And then we're going to combine like terms. 2x and 7x is 9x. 4 and 5 is 9. And then we're going to solve. So we're going to subtract 9 on both sides, and we're going to divide by 9. So x is 9. Okay, now, just like what we did in 7.3 when we were doing all of those properties as converses, saying, you know, if the diagonals bisect, then you can conclude it's a parallelogram. The same is true with this property of the diagonals of a rectangle, and that is, if you know that the diagonals are congruent, then you can conclude that it's a rectangle. Okay, so in this example, it says Leonardo measures the sides of his figure and confirms that they have the desired measures as shown. Using a carpenter's square, he also confirms that the measure of the bottom left corner of the figure is a right angle. Can he conclude that the figure is a rectangle? Explain. And what you didn't see at the beginning of the lesson, there was a little picture, I didn't put it on your notes, but that just saying that the doorway width was 36 inches. So we also know that length right there is 36. So we have these two sides congruent, we have these two sides congruent, and then we have one right angle. So the question is, can we conclude from this information that it is a rectangle? And the answer is yes, because we know that opposite sides are congruent. So that means it's a parallelogram. We'll just use the symbol for that. And then if there is one right angle, then it has four right angles. Remember that property from parallelograms last time. So if it has four right angles, that's one of those properties that specifies the difference between a parallelogram and a rectangle. And so since we know that it has four right angles, we can say, therefore, it is a rectangle. And you can just say by definition. So one key when you're proving something is a rectangle is that you need to show that it's a parallelogram first, which we are doing by saying opposite sides are congruent. And then we need to give a specific property to making it prove that it's a rectangle, whether that be diagonals congruent or whether that be that it has four right angles. Okay, so we're going to kind of follow that same idea. We're going to determine whether this quadrilateral is a rectangle by using the distance formula. So they're going to tell us specifically what they want us to use. So we're going to plot our points. So we're going to plot the point P, which is at -5, 3. Q is 1, -1. R is -1, -4. And S is -7, 0. And I'm going to connect these points using a straight edge. Whoops. Okay, so what we want to do is determine if this is a rectangle using distance formula. So first thing that we have to do, the first step, is we need to know, is this a parallelogram or not? And that's kind of what we were talking about in that last example. If it is a parallelogram, then we know that opposite sides have to be congruent. So we're going to do the distance formula, excuse me, to determine if opposite sides are congruent. So as a reminder, distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. And we're going to check opposite sides. So I'm going to check the length of PS. And when you do the distance formula for this, I'm not going to do all of these. I'm just going to tell you what you get out. And you can check your work is square root of 52. Then we're going to check the opposite side of that. Or I'm sorry, PS is not square root of 52. It's square root of 13. And then opposite of that is QR, and it is square root of 13. And then PQ is square root of 52. And RS is square root of 52. Okay, so we showed opposite sides are congruent, so that means, yes, it is a parallelogram. Now, what we need to know is, specifically, is it a rectangle? And using the distance formula, how can we show that it's a rectangle? Well, we can show the distance of the diagonals are the same so that the diagonals are congruent. So again, we would use distance formula and we would find the length of PR. And if you do the distance formula, you get square root of 65. And then you would do the length of QS using the distance formula, and you would get square root of 65. So the question is it a rectangle? Well, yes, it's a parallelogram. We showed that right here in step 1. And then in step 2, we showed specifically that it was a rectangle because the diagonals were congruent. And so then you can just say yes and let all of your work there be your justification. And I'm going to put a question mark because that's what you're trying to figure out. Is it a rectangle? And the answer was yes. Okay, now we're going to follow the same idea, only this time we're going to do the slope formula to determine if it's a rectangle. So we're going to plot our points on here. So J is negative 10, 2. K is negative 8, negative 6. L is 5, negative 3. And M is 2, 5. And then I'm going to connect these. Okay, so this time they're telling us they want us to use the slope formula. So again, the very first step that I need to do is I need to determine, is this a parallelogram or not? And for it to be a parallelogram, when you're talking about slope, we need opposite sides. So remember, slope will tell you if lines are parallel or perpendicular. So if we're going to say it's a parallelogram, we need opposite sides to be parallel. So we're going to do the slope formula. So as a reminder, slope is rise over run. So y2 minus y1 over x2 minus x1. So remember, if you're looking at a graph, you can just count up and over, or you can do that slope formula. So I'm going to start and do the slope of Jm. And the slope of Jm would be 5 minus 2 over 2 minus negative 10. So that would be 3 over 12, which is 1/4. And now I'm going to check KL because that would be its opposite side. Slope of KL would be negative 3 minus negative 6 over 5 minus negative 8. And that would be 3 over 13. So what we learned there is that JM and KL are not parallel to each other. So this automatically, we can stop right here and say that it cannot be a rectangle. And then you can tell me why, that the opposite sides aren't parallel. So if it's not a parallelogram, it's automatically not a rectangle. So that's the thing that you need to check first. Is it a parallelogram first? And then use some specific properties to determine if it's a rectangle. As a reminder, if it were a rectangle, remember that the key for the slope formula was that would be that sides have to be form a right angle, which means they have to be perpendicular. So remember that that means slope would be opposite reciprocals of each other. So just be thinking through that as you get to some like that on your homework. Speaking of, here's your assignment. So on page 426, you're going to do 10 through 32 evens and then number 40.